Welcome to The Explainer. So today, we're jumping into a topic that, let's be honest, fascinates every single one of us. It's a concept that lives right at that crossroads between wild science fiction and some seriously mind-bending physics: time travel.
Right, let's just dive straight into the deep end with the ultimate what if. This question, it's not just the engine for countless stories, it's also at the heart of some really profound debates in theoretical physics. What would you do, and maybe more importantly, what would the universe even allow you to do?
Before we can even get into the how of time travel, we've got to understand the why. Where does this obsession even come from? Well, turns out it's an idea that's been with us for a lot longer than you might think.
Yeah, this dream of going back, it's not just about fixing mistakes or seeing the dinosaurs. It's way deeper. It's a universal human impulse that's tied to our biggest questions about cause and effect. The paths not taken, and the very fabric of what we call reality. It was a philosophical quest long before science ever got its hands on it.
Okay, but before we get to the physics, there's a really critical pattern in human history we have to talk about, and it serves as a massive warning for any of us who dream of traveling through time.
This quote just nails it, doesn't it? It perfectly captures our track record with world-changing discoveries. We get our hands on something incredible, something that feels almost divine, and we just rush forward, all excitement, before we really stop to think about the consequences.
And this just lays it all out. We harness fire for warmth, and it led to terrible weapons. We learned to fly to connect the world, and it led to bombing from the sky. The atom promised clean, limitless energy, and it gave us the constant threat of total annihilation. And we're seeing it right now with AI, aren't we? This huge rush of optimism, but it's shadowed by some really deep ethical questions. Time travel would be the ultimate godlike power, and our own history suggests we should be very, very careful what we wish for.
So yeah, our own history is a pretty big cautionary tale. But what about the laws of the universe itself? Let's take a look at how physics tries to deal with the kind of chaos that time travel could unleash.
This is really the core question, right? Is the universe this fragile thing that one person could just shatter by accident? Or has it maybe evolved its own defense mechanisms to stop paradoxes? Two of the greatest minds in physics came up with their own, very different answers. First up, the legend himself, Stephen Hawking. His idea, the chronology protection conjecture, is actually pretty straightforward. He basically proposed that the laws of physics themselves will actively conspire to stop big things, like people or machines, from going back in time. In his view, the universe has a serious interest in its own stability, and it's going to stop you from, say, accidentally preventing your own birth.
Then you've got physicist Igor Novikov's self-consistency principle. Now this one's a little more subtle. Novikov basically says, sure, go on back in time, but anything you do there, well, you are always going to do it. Your actions are already woven into the tapestry of history. You can't change the past, because your trip to the past was always a part of it.
And what's so fascinating here is just how different these two approaches are. Hawking's theory is like a cosmic bouncer at the door to the past just saying, nope, you can't come in. Novikov's principle, on the other hand, lets you in, but then reveals you're just an actor in a play that's already been written. Either way, the past stays exactly as it was.
Okay, so if these two heavyweight theories basically lock the past in a vault, is that it? Is that the end of the story? Well, not quite. The rules might be different on a much, much smaller scale. So let's get weird and dive into the world of quantum mechanics. Quantum entanglement. It is one of the strangest yet most proven phenomena in all of physics. You can have two particles linked in such a way that whatever happens to one instantaneously affects the other, no matter how far apart they are. We're talking across the galaxy instantly. This suggests that information might be able to travel in a way that doesn't play by the normal rules of space and time.
And here's the crucial point, the potential loophole. Maybe we can't send a person, or a DeLorean, or even a single atom back in time. But what if we could just send a message? The temporal teleportation of pure data. That might just be how we get around the universe's security systems.
So let's run with that for a second. Let's imagine this becomes possible. How would an ability to send information into the past actually fit in with the massive forces that are shaping our own future?
It's almost a guarantee that a tool this powerful wouldn't just sit in a lab. It would inevitably get tangled up with the two most dominant forces shaping our century: the explosive growth of artificial intelligence and our desperate struggle to adapt to climate change.
And this leads us to this brand new theoretical idea called chrononomics. I mean, just imagine an economy built on what they call temporal arbitrage, basically using information from the future to make perfect decisions in the present. It would be the ultimate, unbeatable form of insider trading.
And this chart just shows you exactly how an AI could put it to work. It could get data about a future market crash and tell you to sell everything. Or it could get a warning about a monster hurricane and guide evacuations with pinpoint precision. The possibilities range from the kind of trivial, like winning lottery numbers, to the profoundly, deeply life-saving.
And that's where climate change really comes into play. This wouldn't be about reversing climate change itself, but about adapting to what's coming with perfect foresight. It could be the ultimate undo button, letting us lessen the damage from a flood or a wildfire because we knew exactly when and where it was going to strike.
Now, this is all fascinating, futuristic stuff. But what's the lesson for us, right here, right now, in a world where we don't have time machines? Well, the real value might be in learning how to think like a time traveler.
That's right. You don't need a flux capacitor to start using these ideas. The very same logic that physicists use to think about paradoxes can actually be an incredibly powerful tool for making better strategic decisions in our own lives and in business.
So here's how you do it. First, think like Nabokov. Treat what you do today as if it's already writing the permanent history of your future self. Second, avoid creating your own paradoxes. You know, those short-term fixes that actually sabotage your long-term goals. And finally, use what we can call temporal data. All the trends, forecasts, and projections out there. Treat them like they're messages sent back from a possible future and use them to act smarter right now.
And that really brings us to the final thought here. Maybe the biggest lesson from all these wild theories is that our obsession with changing the past is kind of a distraction. Whether the past is locked down by cosmic law or not, our real power is always, always in the present. So the real question isn't about how we can rewrite what's already done, but about how we're going to consciously and carefully write what is still to come.